Today we are going to discuss about different types of civil engineering softwares and their uses. So the first one is AutoCAD 2D plus 3D. So as the name says AutoCAD 2D plus 3D, but we are using AutoCAD mainly for the 2D drafting purposes. Suppose we want to create different types of plan, elevation or section, we are using AutoCAD software. Then if we want to make any type of 3D modeling, then we are using Revit Architecture or 3D STAAD software. Then we have STAAD and ETABS for structural designing softwares, and Tekla and Revit Structure for structural detailing. Like if we want to do the drafting of 3D reinforcement detailing, or we want to do a 3D modeling of a steel structure, then we will be using this type of Tekla and Revit Structure software. So AutoCAD being the basic software, we'll be starting with AutoCAD. If you want to create any type of 2D drawing, we are doing that with AutoCAD software. These are the examples of few 2D drawings which can be drawn in the field of civil engineering department, or which are necessary in the field of civil engineering department. This is a sanction plan, you can say. This is another example of a sanction plan. Suppose if we need any type of 3D models, we are going to do that with the help of 3ds Max software. I'll give you a few examples, like this type of customized furnitures which can be done from 3ds Max. Then we can create this type of exterior images like realistic views, these are called. So this type of realistic views could be generated from 3ds Max software. Like these are the interior designing. 3ds Max is basically for interior designers, but like civil engineers can also use it for like exterior modeling or exterior realistic view image generation. Then we have the Revit Architecture software. With the help of Revit Architecture, we are very easily able to draw the plan, elevation, section and 3D modeling. So these are few examples what Revit Architecture software is for. Then we use this Revit Structure or Tekla for this type of structural detailing or structural modeling. One more example I'll show you. Like this is an example of structural detailing and modeling. For structural designing, we are using STAAD and ETABS as the structural designing. So this was just a basic idea, like what are the uses of different softwares. Now we'll be discussing different softwares in details. So we'll start with the AutoCAD software. So guys, you can see the AutoCAD screen is opened over here. First of all, I'll let you know about the graphic user interface, GUI. So these are the menu bar options: home, insert, annotate, prismatic, view, insert. These are the menu bar options. So under the home menu bar option, we have the draw toolbars. Like if you want to draw any object, we can use this line option, polyline, circle, arc, rectangle. With this, we can draw different types of drawings. Then we have the modification toolbar. Suppose I want to move an object, I want to move the circle, I want to rotate a rectangle, I want to copy one circle from the other. So this modification commands will be used in that case. Next come annotations. In the annotation part, we have the text portion, the drafting portions, that is detailing of the drawing. Then we have the layers concept. With the help of layers, we can distinguish different objects with colors, different line types and different types of thicknesses. Then we have the insert option, that is we can insert different types of blocks. I'll tell you about what are the uses of blocks. Then we have the properties option, like we can give different colors to different objects. We can create different types of line types or line thickness which are similar to the layers option. So we'll discuss about that in future as the video goes on. So these are the few basic drawings which we are going to start with AutoCAD. Like this is for the practicing of draw and modify toolbars. So that's if you will be practicing more and more, you'll be having a good command on the AutoCAD software. Because there is a saying we all know, practice makes a man perfect. So the more you practice, the more expert you become. So that is the reason we have included this type of drawing and drafting portions in AutoCAD, so that you guys can practice a lot and you become an expert in AutoCAD. Then we have this type of basic plan and elevations. I'll show you a few examples. This type of plan, elevations and sections. I'll show you a few examples of the live projects that are done in AutoCAD. These are the planning. This is the planning for a G+7 residential apartment. So these are the floor plans. These are the floor plans you can see for the different floors. Then we have the elevation of the similar types as well. I'll show you the elevation. These are the examples of elevations of multi-storied building. So this is another example of the same plan I had shown you earlier. This is the beam details along with the pipe cap details you can see, and a working drawing as well. Like these are the grids. So when there will be grids in a drawing and columns will be there, so this is called a working drawing you can say. These are the examples of column schedules. These are the column schedules you can see. Then we have the detailed plan and section of stairs. These are the few examples of the live projects. This is the example of a sanction plan. Like you can see, these are the different floor plans. This is the elevation part. This is the section. This is the detailed section of the septic tank, and this is the site plan. This is the beam layout details for the individual floors. As you can see, like this is for the first floor, then second floor, third floor, and it goes on. Then we have the reinforcement detailing options, or you can see these are the reinforcement details which are done in AutoCAD. So the motive behind showing this type of projects is you can be able to draw this type of drawing and drafting with the help of AutoCAD. So these are all necessary in the field of civil engineering career. Suppose many of you would like to work as a civil engineering designer. So these are the works you are going to do. This is an example of a working drawing. This is the detailed drawing of the foundation. This is a sectional view. These are my projects. So these are few examples of steel structure detailing. When I was working as a design engineer, these were done by me. So I'll be sharing with you this type of live projects so that it helps you out a lot. So I guess guys, you have a clear idea by now what is the use of AutoCAD 2D. So now in this topic we'll be seeing if we want to draw this type of exercise, if we want to draw this type of objects, how we will be drawing. So I'll be showing you in step-by-step format. So first of all, we have to take a circle. So this will be the process of drawing a circle. We have to give a different radius for different circles. So these are the circles we are drawing. We can change the properties of the circle with the help of property option. So each and every details, I'll be making a separate video on the draw commands. I'll be making a separate video on the modify commands. We'll be discussing each and everything in details. So since this is just the introductory part, I'll be showing you only the basic concepts. So three different circles are drawn. Now, as in the picture we can see, like there are a lot of different circles with the same radius. So what we will do, we'll be drafting only one circle, then we'll be using the copy option. We'll be making a copy of the same circle in all the other positions. Or there is similar command that is called array. So we can just give the number of items we need, then automatically that number of circles will be drawn as you can see on the screen. So the next step will have to, so the next step is we'll be creating this part of the drawing. So I'll show you the step-by-step process. Let's see. So we'll give a degree, let's say 30 degree. Then we'll be creating this part of the object. So we'll be creating on one side, and the other side will do the opposite mirror. So there is a command named mirror. We'll see the use of the mirror, but this is the offset command. Suppose we have this line, we want to create a copy of this line at a distance. So we just need to select the offset command. We have to give this distance, a line will be copied. Then we'll be creating this portion. With the help of arc we'll be drawing. We'll be creating on the single side, and we'll be then using the mirror option. So you can see the use of the mirror option now. So with the help of this, we'll be creating different types of these exercises so that it helps you in practicing a lot, because the more you practice, I have already told you, the more perfect you become. So you have to create this type of different basic exercises to master yourself in AutoCAD. Done with a basic exercise, we'll be starting with this type of different plans. This is an example of a basic plan. So the walls are being drawn first, then we can see these spaces. These are for creating doors and windows. We'll be trimming these portions and we'll be placing the blocks of the doors and windows, which are ready-made available. So I'll show you the process, how the trim will be done. Like these portions will be omitted and the doors and windows will be placed in this position. So like this is the process how the trim option is going to be executed. Then this is the frame, a door frame we are drawing. We'll be placing the block of a door. So like every time we'll be using a door in a plan, we won't be creating each and every time, right? We'll be creating a block of the single door, then we can do the modifications. Like we'll be placing in the plan, suppose we have a different dimensions, then we have to do some modifications with the dimensions. So that can be done. So this is the creating block option, you can see. So once we are done with creating different types of blocks of different shapes, we'll be placing the doors and the windows one by one in the plan. So after the plan is done, we'll move to the elevation and section part. So now we'll check what is the process of preparing elevations and section. Since we can see like we have the plan over here, we will take reference lines to create different exterior views like north, south, east and west. We have to create different exterior views, which will help construction engineers to construct the building, because they will have a clear idea before construction that what they are going to get constructed. So you can see from this plan we are taking the reference lines. So these are the reference lines. Then we will be creating the ground level, then the plinth level. We'll have to take a sill level from there. So this is the lintel level, you can see. We are taking the reference for the windows and doors. So this is the process how the elevation is done. If it is a multi-storied building, we can even take the reference, like suppose we have a G+3 residential building. So if we have similar plans or typical plans in each floor, then we can simply copy the ground floor elevation and place it on the others. But if we have a different plan, then we have to create a different type of elevation following the same exact process. So here you can see, guys, we have a like typical floor plan for this project. So we are just copying the ground floor to the first floor and the second floor. So this is the elevation view, you can see. That's the step-by-step process of creating elevations, exterior elevations. Now we'll be seeing how to draw sectional elevations. Suppose we'll be taking a section line along this XY, along this line. Then we'll have to take the reference line, suppose like where are the windows, where are the doors, from which portion the wall is getting cutted. This type of reference line we'll have to take. Then we have to create the ground level, plinth level, the similar process as it was shown in elevation. So that is the similar process. So I'll skip the video a bit. These are the reference lines we have taken. Then we'll be placing the windows. This we could see we have a section of a window within the section of the wall. Then we'll be placing this full windows one by one. So this is the sectional elevation. I hope you got a basic idea about why to use these sections and how to draft these sectional elevations. So the main purpose behind drawing sections or drafting the sections are, suppose we want to show the dimensions, we want to show the thickness of the wall, we want to show the height of the door or the height of the window, the width of the window or the lintel details. If we want to show any detailed drawing, we have to show that in the sectional elevation. Then we come up with one of the most important feature, that is RCC column layout. So here we can see the column layout is already been done and the column columns are marked with red color layers so that it can be easily distinguished from the other columns or the other objects. So here the process of creating construction drawing or working drawing that is going on. So first of all, we'll be selecting only the columns. Only the columns will be visible on the screen. Then we'll be creating the center line drawing. So this is the center line drawing going on. Then we'll be creating different bubbles for giving grid numbers. So we are creating the bubbles now. Then we'll be giving the grid numbers like A, B, C, D, like A, B, C, D in a single row and 1, 2, 3, 4. So like this we'll be marking the columns. So let us say in this direction we have marked A, B, C, D, E, and in this direction, like vertically we have marked 1, 2, 3, 4, 5, 6. So depending on the naming, depending on the numbering, we'll be naming the columns. So this column will be named as A1, this will be named as B1, and it goes on. So we'll give you like basic idea or detailed idea in the next videos. This is just about giving basic informations. So these are the column namings going on, you can see. After that, we'll be giving the dimensions, the difference between each grids, because that is going to help us in construction. Because for these columns, we'll have to do the excavation. So depending on the working plan, depending on the distance between the grids, we'll have to do the excavation process. So this will be the final outcome. Like we have the plan, we have elevation, we have section, each and every details present here. We have the layout also. So this is the purpose of using AutoCAD. Like if we want to create sanction plan, we want to create any type of drawing for a building section, be it plan, elevation, section, or any type of structural detailing, we are going to do that with the help of AutoCAD. After we are done with the 2D part, that is creating plan, elevation, sections, working drawing, we can move to the 3D modeling. So here we can see like we had created a 3D model of a building structure, and then we can apply textures over here, like we can apply materials, different colors. So we have different types of textures and colors which is already loaded in the Autodesk material library. So this is the Autodesk material browser. From there we can choose different types of colors, materials, be it grass or glass, concrete, brick, wood, any type of textures can be chosen. Or there is another option, like you can download any type of texture from the internet, from Google. You can download a picture, you can apply that exact texture in the 3D model of the AutoCAD, the 3D model that we have generated in AutoCAD. Then we can create a realistic image. So this is the rendering process going on. Rendering is actually the realistic image generation. So the realistic image means the actual building after the construction, how it will look like. We are going to create a virtual image of that building in AutoCAD 3D software. So this is the like rendering going on. You can see a clear realistic image. So before construction, I can show it to my client that how actually the construction is going to be, or how actually the building is going to look like. So guys, there comes the concept of using advanced 3D modeling softwares like Revit Architecture, 3ds Max and SketchUp, because you can see like the quality of image that you are getting is not up to the mark as required in for exterior images or interior realistic images. So now we'll be checking the use of Revit Architecture software, what is its how it is beneficial for students of civil engineering department or professionals from civil engineering department. So let us check the Revit Architecture software. With Revit now, I have already created a planning. You can see the plan, the elevation of the building, the respective 3D as well. Because see, I want to show you the difference between AutoCAD and Revit. Actually, the concept goes like this. AutoCAD is used by drafters and Revit is used by engineers. Once again, I'll repeat. AutoCAD is used by drafters and Revit is used by engineers. See, here we will be doing the planning part. The elevation will be going on, like we have the respected, let's say east, west, north, south, all the elevations that will be automatically drawn. Will have the 3D view as well. Because in the, like we have in AutoCAD the draw toolbar options, the modify toolbar options, right? But in Revit we have this build toolbar option, wherein we have the walls, doors, windows, we have furnitures, each and every furnitures that is required in the component part. Then we have columns, roof, ceiling, floor, each and everything that is required for a building is present in Revit Architecture software. Then even we have the structural part as well. We'll be discussing that later. So let us see the video. Like let us give you a short basic idea about the Revit Architecture software. Now let me give you a basic idea how to draw different kinds of walls with different thickness and height in Revit Architecture. So we'll start with the process. See, first of all we are choosing a wall option, then we can give the distance. We can move the cursor in the respective direction. So this is the wall going on. So unlike in AutoCAD, we only do the 2D part. Here we can see the respected elevation as well as the 3D part, as I already told you in the basic part. So we'll be checking each and every the 3D model, the elevation and section as well. So this is the concept of putting the doors and windows. So we have n number of doors and windows which is already loaded in the Revit Architecture software. So we can simply select from that door options, we can select any type of door and place it on the walls. We do not have to trim any wall portion as we have to do that in AutoCAD. So guys, the main concept of showing you this Revit Architecture after AutoCAD is why we won't be using AutoCAD 3D and we will be using Revit Architecture for better 3D realistic images or for like proper realistic image generation. Because it reduces a lot of time. You can see guys, right? Because you are selecting the window, you are placing the window options. If you want to do any type of modifications, you can do that. So after the doors and windows are placed, we'll be going with the floor option. So this is the plinth we have created. Then we are creating the roof option. So this is the elevation part. You can see this is one-sided elevation. You can check all other sides. See guys, we have east, north, south, west, 4 different elevations. So we have a project browser option in Revit Architecture. From there we'll be able to change the elevation views. So next comes the concept of section. So this is the sectional line you can see. So once the sectional line is drawn, in AutoCAD what we used to do, we used to take reference lines for the sections. Then from those reference lines we had to create the sectional drafting. But in Revit we had seen, we had just drawn the sectional line, we got the sectional view. So this is the most important and interesting feature of Revit. It reduces a lot of time drafting the section, and like this automatic section is generated, so there is no point of any error, right? So move to the next part then, like placing the furniture. So we have the furniture gallery, or we have the component gallery from where we can import n number of furniture. Suppose we need any bed, chair, sofa, any type of furnitures we require, we'll be searching it from the Autodesk Revit library. From the library we'll be placing the furnitures, and even we can get the 3D models, or we can visualize the 3D models of the furnitures. Like this is the elevation view. I'll show you the 3D models of the furniture. So guys, in this video you can see the furniture layout, the 2D furniture layout. So once the camera is set, I'll be setting a camera over here. Then we'll be able to see the furnitures in 3D format. So the camera is set. This is the furnitures in 3D format. Then we can create different types of realistic view. So that process is going on. Few customized roof shapes I'll show you. So these are the few customized roof shapes. Now I will show you modeling of a residential complex in Revit Architecture software. So we can import AutoCAD plans in Revit as well. So this is an imported AutoCAD plan. We are creating the topo surface first. This is the topo surface created. See, we can apply different textures as well, like the green grass. And this is the planning going on. And you can see the simultaneous 3D view can also be seen. So as I already told you, there are n number of doors and windows loaded, which are being placed in the plan. Then we can place the columns. Then we can do some exterior modeling as well if you want to do. Then the floor option. Then we can place the stairs which are ready-made available. So see, very quickly we can draw a multi-storied building. We can draw the elevation of a multi-storied building very easily with the help of Revit Architecture. I guess by now you have already understood what is the use of Revit Architecture, like what is the benefit of Revit Architecture. Because like very soon we can create a plan, an exterior elevation with a reduced time than AutoCAD, because AutoCAD takes a lot of time to create the elevation, planning, then section, we have to do the 3D modeling part separately. Unlike in Revit, if you are doing only the planning portion, we can see the respective elevation part, we can see the respective 3D model as well. Then as the video goes on, I'll tell you more interesting features about Revit. One of the most important part is we can create automatic schedules. Suppose we want to create room schedules. So here we can see like different rooms are marked with different colors. These are applying color legends. Suppose I want to mark my bedroom with a different color. I want to mark the drawing room with a different color. So that during the presentation it looks good. So we can create like that. After creating the color legends, we can create automatic schedules. Like we'll be getting the automatic carpet area of the room. So like this, the schedules of quantities and the schedule of rooms are created. Now we'll see the most important feature of Revit, that is creating sections. So we can see like there is a section line that is drawn over here. So in AutoCAD, how we do, we will be drawing the section line over here. Then we'll be taking references from the doors, windows. That process will be following. So in Revit, we do not have to follow that process. We simply have to draw this section line. Then we'll be getting the automatic sectional view. This is the automatic sectional view we can see. So you do not have to waste unnecessary time on the section, because you are getting a ready-made sectional view. Then you can represent the drawing in this predefined title blocks which are already there in the Autodesk library. So guys, you can see you will find this type of predefined title blocks in Revit library. So you can drag that title block from the Revit library. You can give your presentation for the plan elevation section in a proper sheet, and then you can use it for the print purpose. This type of realistic images can be created in Revit. These are for the exterior output. Now I'll show you few isometric views of the interior part. This is the interior part. Then the most important feature or the exciting feature in Revit Architecture is the walkthrough. This is the walkthrough. This type of walkthrough can be generated in the Revit Architecture software. See, you can see the customized furnitures which are predefined in the Revit library. This can be properly visible right now. So all these furniture, these are available in the 3D format in Autodesk Revit library. So you do not have to give any effort drawing the furnitures or doing the furniture layout, creating sections, placing the stairs. This effort you do not need to place in Revit. So I'll skip a bit. See, you can change the daytime like morning, afternoon, evening. You can use light effects for realistic images. Projects on Revit Architecture done by our students. I'll show you one by one. This is the back view. All these projects are done by students of our institute. So once you practice Revit, you will also be able to do this type of projects. I guarantee you that. Now these are few advanced projects with advanced light effects, texture and all. So all these are done by students of our institute. So this is the parametric function of Revit. So that's all for Revit. Now, like we have seen planning and modeling softwares. Next, we are going to see structural designing softwares like STAAD Pro and ETABS. So now we'll be starting with the structural designing softwares like STAAD Pro and ETABS. But before starting with STAAD Pro, I'd like to share the workflow method that is used in STAAD Pro. So that is divided in two parts. The first part is analysis and the second part is design. So in analysis part, first of all, we do the structural modeling. Then we apply the properties in it. Then after the application of load, we check the shear force, bending moment, deflection, displacement. All this we used to do theoretical calculations in strength of materials, right? So we'll be getting the detailed result with the help of the softwares. Then comes the design process, which is checking the stability of the members that are used in the structural modeling. So first of all, let me give you a clear idea about the basic user interface of this STAAD Pro software. So as you can see, this is the grid. We can modify the grid with the help of this edit option. So this can be modified according to our wish. This is the data entry area wherein we can create different types of nodes and members. So I'll tell you in brief what nodes and members are. Nodes are actually the joints and members are the beams and columns. Then we have the toolbars over here. There are total 17 toolbars in STAAD Pro. Then this part is called the page control, wherein we have different pages like the general, analysis, print, designing, geometry, these different types of pages. So as the video goes on, I'll give you each and every detail. Start with the structural modeling process. So here in this video, we can see first the nodes are created, then the members are created. Once the plan is created, then we'll be creating the columns. So we had selected the node options, then we'll be using this translation repeat. So with the help of translation repeat, we had created the columns. Then again with the help of translation repeat option, we'll create multiple number of floors. So suppose we want to create a multi-storied building, we want to do the structural designing of a multi-storied building, then we'll be using this method to create a multi-storied building in STAAD Pro. So once we are done with the modeling, then we'll go with the property application. So this is applying the concrete properties, wherein we can see we have the rectangular option, we have the circular option, we have other options like T, trapezoidal. So according to our wish, we can apply the property. So here we are applying 0.75 meter, that is 750 mm concrete column. Then we'll apply a rectangular beam or a rectangular member, we can say. So once we have defined the properties, now we have to apply them on the members. That is, we have to first select the members on which member we want to apply the specific properties, or we'll be assigning the properties on the exact members. So we have applied the column properties, then we'll be applying the beam members. That is, we have already chosen rectangular members, that is of 500 mm into 750 mm thickness. So by this process, we are applying the properties. Then we can have a 3D visualization of the properties that are applied. This is the frame structure, the 3D view of the frame structure that can be seen. Then we'll have to start with the process of load application. So for that, we have to define the load case, that is, we are defining the dead load case. And under the dead load case, we have to apply the self-weight, member loads, nodal load, each and every load that we want to apply that can be applied from this load option. So first of all, here we are applying the self-weight under the dead load category. Then we have to apply the member loads. That is, here we can see the application of member load in the form of uniform force. Then we can apply floor load. So this is the graphical representation of the applied member load on the beam members. Now we will be applying the floor load. So this is the floor pressure we are applying. Then we have to define the Y range, that is the minimum and the maximum height. So after the application of load, we'll be moving to the analysis part, as I already told you in the workflow method. We'll be checking the shear force, bending moment, deflection, displacement in the analysis process. Let's say for a particular member, if we are applying this type of loads, UTL, point load, uniformly varying load, then after the analysis process, let us check the shear force, bending moment, that is the results of this particular member. So let us now check. So this is the deflected shape of the beam, as you can see. Then from this portions, we'll be checking the displacement, shear force, bending moment. The minimum and maximum values will also be mentioned in this graphically, as you can see. So these are the results which we use to calculate in the strength of material subjects. So the work of STAAD Pro is to reduce the effort which we used to do theoretically. So as we did for a single member, so now we'll check the analysis process for this multi-storied building. So as we can see, there are 0 errors and 0 warnings. So we'll move to the output file or the post-processing mode, that is the result view options. We'll go and check. So we'll be able to get the reactions. I'll show you. So these are actually the shear force and bending moment of individual members of this multi-storied building. These are the axial forces. We can check the plate stress analysis as well. So after the application of live load or dead load on the floor slab and the stress result generated, this is the graphical version, and you will get the tabulated result as well. Now after the analysis is complete, we'll move with the design process, the concrete designing process. I'll show you the results. So for a particular member, beam number 36 of this project, we can see the results, that is the compressive strength of concrete, the yield stress of steel primary and secondary, the length of the member, the section properties of the member, the clear cover that is assigned. Then at each and every detailed sections will be getting the area of steel. This is in square mm. Below in this report, we'll get a detailed report of the number of rods used. See, we can see the number of rods used, what will be the dia of the rod. Even for the shear reinforcement, we can see the spacing as well. So this type of results, detailed RCC design results, will be available from the STAAD Pro software. Then we can see the cross section of the column, wherein we can see the number of bars used, the bar size, area of steel in percentage, load coming on the column. Each and every results will be able to find out. Then for a beam section as well, we'll be getting the detailed result just similar to that of the column. So let us now move to the steel structure part, the designing of steel structures. For a particular steel profile, we'll be able to get the exact length that is used and the unit weight that is used. So from there we can easily calculate the rate, that is the quantity estimate can also be calculated. Then you can see, like for this particular member, it shows it is failing. That means it is not passing the structural stability. And the other members you can see, it shows it is passing. So these members pass the structural stability. So in case of these properties as well, or we can change the design parameters. Now I'll show you a few projects related to STAAD Pro. Like for this particular member, if we want to find the stress, the corner stress at any particular position, we'll be able to find that. Here we'll be getting the tabulated result as well. So this is the seismic reactions that are developed in each and every joints due to the seismic forces. These are the shear force, axial forces and bending moment. This is the graphical representation. Then we can see this is a 3D model of a multi-storied building. This is a transmission tower, water storage tank. These are all projects will be covering up in this entire course of STAAD Pro. Again, a multi-storied residential building. This is the detailed view of the column section. These are the bending moments. This is a light project. This is a steel structure tower. This was done by me when I was working as a civil engineering designer. So all these projects, as I have already told you in AutoCAD, I'll be sharing with you. So similarly, I'll be sharing the projects related to structural designing with STAAD Pro and ETABS, so that it helps you out a lot. Then we have this type of projects. These are all done by the students of our institute. This is a multi-storied building. This is a steel structural building. This is again a steel truss shed. These are the skid base frame of oil and gas industry. Again a skid base frame. This is the application of wind load. Guys, I believe I am able to give you a basic idea about the STAAD Pro software. So in the next videos, I will be discussing ETABS and other softwares as well. So see you in the next video. Guys, I believe I am able to give you a brief idea about the STAAD Pro software. So in the next videos, I'll tell you in detail about the ETABS softwares, which is another structural designing software. Guys, I believe I am able to give you a brief idea about the STAAD Pro software. So in the next video, we'll discuss about another structural designing software, that is ETABS.